But humans enter the carbon cycle too. I mean, yes, we are made of carbon. Yes, we undergo cellular respiration, but we change the cycle a little bit as well. We use fossil fuels. We take fossil fuels out of the earth, which they weren't meant to be. And when I say that, I just mean not to the degree they currently are. Oil, natural gas, and coal do get back into the environment through natural means, through earthquakes, through volcanoes, through different activities. But humans are expediting it. We're speeding it up. And the way we speed it up is by burning fossil fuels. So this is an overview of what fire is. And I mention this for a reason. So you need some sort of, not necessarily heat, but some sort of source of a flame. You need a fuel. Here I have wood. Wood also made of carbon. This could also be a fossil fuel. So most of our fuels have carbon in them because the bonds carbon makes with other molecules has tons of energy in it. And then you need oxygen. If you don't have oxygen, that fire will not sustain itself. As a result, you get your fire. You'll get some ashes, and then you get a gas which you don't see and you don't smell, but we make carbon dioxide. And that's just because we have oxygen plus carbon. And it doesn't matter what you're burning, whether you're burning wood, whether you're burning leaves, whether you're burning a fossil fuel, essentially anything you burn, if it has carbon in it, it's going to make carbon dioxide. There's no doubt about that. And this is where humans are interfering with that carbon cycle. So here's that carbon cycle again. You know, what we're doing is here we have fossil fuels. Fossil fuels are carbon storage. That carbon was going to stay there probably for another 1,000,000 years, but it's not anymore. What humans are doing is by burning it, we are reintroducing that carbon back into the atmosphere. And that in and of itself isn't bad. That carbon will be used by plants, it will go into the ocean. It's just our environment and the organisms in our environment aren't adapted for that much carbon all at once. And we'll talk about some of the repercussions of that. But just thinking about where we fall in here is we're just taking carbon that was in one place, a carbon storage, and re-entering it into really a fast carbon pathway. In the atmosphere, that carbon is accessible to a whole bunch of things, to the oceans, to our plants, etc. But depending on which fossil fuel we're burning will actually depend on how much we're disrupting the carbon cycle. So remember I showed you those molecular formulas earlier of coal, of oil, and of natural gas. And the reason I was pointing those out and the number of carbons in them is because that is going to make a difference of how much carbon dioxide is released. So this graph is showing those three fossil fuels, gas, oil, and coal. And then it's talking about how much carbon dioxide is released per kilowatt hour, meaning per really unit of energy. We use these three fuels to light a light bulb. How much carbon dioxide is released by lighting that same exact light bulb? And if you think about it, you should be able to figure this out. Which one of these do you think will release the most? Which one do you think will release the least? Well, it depends on how much carbon was in that molecule. So if we look at these, coal releases the most carbon dioxide of the other, or between the three different fossil fuels. Remember, coal had the most amount of carbon in it, whereas natural gas, that had one carbon, releases the least amount of carbon dioxide. So you may actually see commercials for gas companies saying it's a cleaner energy, and it is. It's still not 100% clean, it's still releasing carbon dioxide, but as compared to coal, it is a much cleaner gas, a much cleaner fossil fuel for us to be using. So on the test or on a quiz, I won't ask you these numbers. I won't ask you 0.8 or 1.4. What you should know though is coal releases the most, and then oil, and then natural gas because of the number of carbons in them. This is kind of just a side note of what's been happening in the United States when it comes to our electricity. And I really want to point out these gray ones. So these gray ones are representing our exhaustible resources. And as you can see, natural gas is actually higher than coal. And it's getting even higher. We're moving away from coal and more into natural gas. A lot of this is because we're finding new ways, such as fracking, to get natural gas. And it's a lot cheaper to extract than coal. So we in the United States are kind of moving in a better direction, at least by getting away from coal. Natural gas still isn't great, but it is definitely better. Our use of inexhaustible resources is increasing. Here we have hydropower, wind power, and other inexhaustible sources. You know, they make up still only a small portion of our energy, but they are getting bigger from year to year. This is really important because us creating energy is actually releasing tons of carbon dioxide into our atmosphere. This number, which I won't test you on, in the United States alone, we use 4.08 trillion kilowatt hours. A kilowatt hour is the number of kilowatts used in an hour. So as an example, if you have a 100-watt light bulb, that's the equivalent to running that 100-watt light bulb for 10 hours. But we do that 4.08 trillion times. So although, yeah, we're using more natural gas, we're still using a ton of it and releasing a lot of carbon dioxide in the meantime. So again, our fossil fuels are made from non-decomposed organisms from millions of years ago. Coal, made from land vegetation and has the most amount of carbon, therefore releases the most amount of carbon dioxide, whereas oil and natural gas are made from the compaction and heat of aquatic plants and aquatic animals. These both have less carbon, methane or natural gas having the least, therefore releases the least amount of carbon dioxide. The reason this is a problem, fossil fuels are a problem, is that humans burn them. And that carbon that was stuck in a slow carbon pathway, that was stuck in fossil fuels, has now re-entered the system. And we'll talk about the consequences of that next.